All right, guys, we're going to learn all about polynomial functions and modeling, but mainly all about polynomial functions. It's a lot of slides today, but they should be pretty quick, and there's a lot of facts. So make sure you take good notes and get all the facts down you need to know about polynomial functions. All right, first thing, what would polynomial function looks like? This first little picture right here, polynomial function is given by functions like this. The a stand for the coefficients, and the x's are your x's with exponents on them. The last term is usually a constant, which means there's no x with it. And they like to put them in decreasing order. Like if you look at the exponents there in decreasing order there, and the a are whole numbers. Now here's some examples in here. This is actually better. This bottom picture. If it's a constant function, it means there's no x. It may look like f of x equals 3, f of x equals 4, or the exponent on the x is a 0. Now, the biggest exponent in a polynomial function is called the degree. The leading term is the term that goes with the degree, and the leading coefficient, which we're going to do with the most, leading coefficient is the coefficient in front of the leading term. Wow, that's a lot of stuff. So let's look at another one. Linear looks like this, where degree is 1. So we'll roll over to the next one. The degree is 1, 2/3 x plus 5. Degree is 1 because that's the exponent on the x. The leading coefficient is 2/3 because that's what's with the degree term. Quadratic is x squared. F of x is 4x squared minus x plus 3. The degree is 2 if it's quadratic because it's the biggest exponent. The leading coefficient is 4 on that one because that's the coefficient of the leading term, 4x squared. Cubic has an x cubed plus 2x squared plus x minus 5. The degree of a cubic is 3 because it's the largest exponent. Leading coefficient in that one is 1 because if you look at the x cubed term, right here the leading term, there's a 1 in the front. Quartic means the degree is 4. The biggest exponent is 4. Negative x to the 4th, blah, 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 blah. The degree is 4 because that's the largest exponent. The leading term is negative x to the 4th, which means the leading coefficient is -1. The biggest words you need from here, make sure you know what degree is and leading coefficient is. And these terms are good too, but those are just special names for those special polynomials based on what the degree is. Okay, got a couple examples here of just what a couple of these look like. Here's a quadratic because if you look at the function here, it's an x squared minus 2x minus 3. The largest exponent is a 2, which means it's quadratic. Went ahead and factored it. When I factored, I found out that the zeros are -1 because that's what makes that parenthesis 0, and positive 3, which makes that parenthesis 0. So look at my graph over here. Graph of a quadratic is a parabola. Notice it crosses the x-axis where the zeros are, -1 and positive 3, because zeros are x-intercepts. Look at my x-intercepts here. The same thing as the zeros. The y-intercept is always the constant term, which is 3, -3. Notice it crosses the y-axis at -3. The maximum is -4. Sorry, the minimum is -4. The bottom point is -4. Now, when they give you a minimum value, they want the y. It occurs that x is 1, but the minimum value is the y coordinate. There is no max. The domain of every quadratic is all reals. It goes left and right forever. The range goes from the minimum to forever, -4 to +1. So that's what a quadratic looks like. A cubic one looks like this one, right? Function is x cubed. Went ahead and write the factored form of that, which once you get a factored form, you can write the zeros. Remember, zeros are your x-intercepts. So over here is the graph. There's an x-intercept at -4, 1 at -1, and 1 at 3. The same thing as your zeros were. They're the same thing. The y-intercept, again, is the constant term at the end. It crosses the y-axis at -12, right there. The min and max, you have to find those on the calculator, which I will show you how to do that in class tomorrow. The domain of any polynomial is going to be all reals, -infinity, +infinity. Cubic is going down forever and up forever. There's no max there's no absolute max. There are a max and a min. There's a max here and a min there, but they're called relative because it's not the graph does go below them and above them. The range is all reals because it is going up and down forever. All right, polynomial functions look like this whole first set right here. These are all examples. That's a quadratic. There's a constant function. There's a cubic function. There's a quartic function. Those are polynomials. These down here are not. And I'm going to show you why they are not. It's not a polynomial function if it has a sharp edge to it or a sharp turn in the graph. That's an absolute value graph. There's a sharp turn right there. This one is not because if you look at the sentence at the bottom, the domain of a polynomial function is all real numbers. Notice the domain of this one is not all reals. It starts at -1 and goes to the right, so it doesn't go left and right forever. The next one here also has a sharp turn. And the last one has a break. It cannot have a break in it. It cannot have a hole in it. No breaks or holes or no sharp edges or sharp turns in the graph. If you look at the polynomials, they're all smooth curves up here. Either a line or a smooth curve, and there's no breaks or holes in any of them. All right, continuous, a couple more words here. Continuous is when a function, our polynomial functions are continuous because if you look down here, there are no holes or breaks in the graph. It's also smooth. There are no sharp corners. So this is what a continuous would look like. That would actually probably looks like it could be a cubic. This is a discontinuous one because there are breaks in it everywhere. There are holes in it. That's considered a hole right there. This is a discontinuous also because if you look right there, there's a hole in the graph. So it looks almost like the first one, except there's a hole in it. No holes, no breaks, no sharp corners. Otherwise, it's continuous, and polynomial functions are continuous. They're all continuous. All right, a couple things here about even and odd degrees. If you have an even degree like x squared, x4, x6, x10, look what the ends do. The ends go the same direction. Either both ends go up or both ends go down. Both ends go up, both ends go down. That's what evens do. Odds do just the opposite. If it's odd, that's x cubed, that's x5, that's x7, that's x9. If it's odd, the ends do different things. One end's going down, one's going up. One's going up, one's going down. One's going up, one's going down, one's going down, one's going up. Now, one more thing about that. Go back to the evens. If it's even positive, like that one, they're both going up. If it's even negative, like that one right there, the leading coefficient's negative, it's going down. Positive, both ends go up. Negative, they both go down. Okay, that's even. Now, an odd, a little bit tougher. If it's positive, the left goes down, the right goes up. There's one right here. There's a positive x9. Left goes down, right goes up. If it's negative and odd, the left goes up, the right goes down. The left goes up, the right goes down. So, one more time. Even, both ends go the same direction. If it's even positive, both ends go up. If it's even negative, both ends go down. If it's odd, positive. If it's odd degree, positive. Left down, right up. If it's odd negative, right up, left down. Oops, got that backwards. Left up, right down. Sorry about that. All right. So what they're going to do first, going to give you a matching one here and ask you to match the graph with the function, even though, and all you need to know is what, let's look at A. A, first of all, the degree is 4. So on A, the degree is 4, and it is positive, which means it's even positive, which means both ends go up. So A has got to be D. A has got to be D. If I look at B, right here, B has, it's odd, it's 3, and it's got a negative. So it means it's odd negative, which means it's going to go up to the right, up to the left, down to the right. That's B, so B is B. C, if I'm looking at C here, it's x to the 5th, which means it's odd, and it's positive. Odd positive is going to go down left, up right, so that's this one, that's A. And then D is an even, it's 6, which is even, and it's negative, which means both ends are going down, which is C. And of course C was doing a little left, so probably it's going to be C. All right. A couple more things here. This says determine whether 2 and -5 are zeros. The way you tell that is you plug them in and see. So I'm going to plug 2 in first. And the way I'm going to know if it's a 0 or not is if when I plug it in, it actually equals 0 when I work it out. So I'm going here. So I get 2 cubed is 8. 2 squared is 4. 7 times 2 is 34. That's 15. If I work all that out, I get -7, which is not 0. So 2 is not a 0. Let's try -5. If I try -5, I'm going to plug -5 in. -5 cubed, that's a cube, plus -5 squared. Let me do that. -5 plus 15. Okay, work that out. I get -125 plus 25 plus 85 plus 15. Working out real quick on my head. That's 0. So -5 is a 0. 2 is not a 0. That's all you have to do. Plug it in, see if you get a 0. Find the zeros. If they give you factors, they're going to say find the zeros. This is probably the easiest thing you're doing today. The zeros are just whatever makes each factor become 0. So the zeros on this problem are going to be 2, because that makes that one 0, that makes that one 0, that makes that one 0. And what makes that 0? -1. So those 2 and -1 are the zeros. Now, When a 0 happens more than one time, like that one happened, the 2 happened 3 times in that one problem. It happened 3 times. That's called multiplicity. So what I'm going to write is my zeros are -1, which happened 1 time. 2 happened 3 times, so I'm going to put 2 with multiplicity 3, meaning it occurred 3 times in my factors. Multiplicity. Okay, even and odd multiplicity. If a factor happens more than once, and it happens like the last one happened 3 times, at x minus 2 3 times, if it is odd, then the graph crosses the axis right there. Just crosses like you would think it was. Remember, a 0 is an x-intercept, so the graph's going to cross right there. Now, if it's even, what's going to happen is the graph's going to be tangent to it. So that last one, my zeros were, I had a 0 at 2 and 1 at -1. So if I were to graph like a rough sketch of that graph, this is very rough, by the way. What that would tell me is they both had odd multiplicities, which means it would cross at -1 and cross at 2. And because it was odd, I think, it would go like, something to that effect. Actually, it was even, so it would do something like that. It would cross there. Now, if one had an even multiplicity, let's say the 2 happened 2 times. Let's say we had like x minus 2 squared and x plus 1. What would happen then is my -2 right here, it would be tangent to it. It would do this. It would like bounce off of it and then go through the -1, or through the +2. I actually did that backwards. I graphed that. If the -1 was even, oh my gosh. Let me do that one more time. Sorry about that. So if I had x plus 1 squared and x minus 2. All right, -1 would be a 0, and 2 would be a 0. And -1 had multiplicity 2. It was even. That means when it touched the -1, it would actually bounce off of it. And would actually pass through the 2. Okay, so if it's odd, it passes through it, the graph does. If it's even multiplicity or even degree, it just bounces off. Hope that was okay. We'll talk more about that tomorrow. Sorry, I messed that up a little bit. All right, almost done here. It says find the zeros of this function. What I'm going to do is I'm going to factor it. They're going to have you factor a couple of them and find your zeros. When you have 4 terms, the only way to factor is by grouping. So I'm going to group the first 2 together, make it x squared, x minus 2. Group the second 2 together, which I'm going to take out a -9, which would leave an x minus 2. You always want the same thing inside. So it gives me, take out the x minus 2, that leaves x squared minus 9. So it gives me x minus 2, and that's the difference of squares. X squared minus 9 is the difference of squares. You can write that x plus 3, x minus 3. So your zeros would be 2, -3, and +3. Those would be your zeros. Your zeros come from whatever make your factors 0. And also, look at the graph right here. I went ahead and showed you the picture of the calculator graph. Look where it crosses the x-axis. It crosses at -3. It crosses at +3. It crosses at +2 because that's where the zeros were. And it crosses there. It doesn't just bounce. It crosses because there were all odd multiplicities. All right, last one here. Factor this one, or find the zeros. So to find the zeros, you got to factor it. So I'm going to say x squared plus 9. And x squared minus 5. And that's the only way, that's all I can do to factor, but I've got to figure out what makes those factors 0. So I'm going to come over to the side and solve them. I'm going to do x squared plus 9 is 0, and x squared minus 5 is 0. Move that 9 over, and I get -9. Take the square root. If I take the square root of both sides right there, I get plus or minus 3i. Do the same thing here. X squared, move the 5 over. Take the square root. And you get plus or minus square root of 5. You can't break 5 down. So those are your zeros, and that's okay if you get zeros like that. All right, this is a huge slide. This is the last one. Not a huge deal, but it's very important here. Every polynomial function of degree n, whatever the degree is, that's how many zeros it has when you count the multiplicity. All right, when you include multiplicity, whatever the degree is, that's how many zeros it has. So, real quick, if I have this right here, if I have f of x equals x cubed minus 2x plus 1, the degree is 3. The degree is 3 because that's the biggest exponent. It also tells me that's how many zeros there are. That's how many zeros I need to find, or how many zeros there are. One more thing we did not do in the video, we will do in class tomorrow. We're going to use our calculator to help find zeros sometimes, and I'll show you that. It's easier to show you that in class than on the video, so we'll do that in class tomorrow, and I'll see you then.